So following on from the previous summary, if you have a function f of x, it could be any function. Let's say for this example, f of x equals x to the power 3, and so your function will look like this, to the power 3. Now if you have f of kx, let's say, what will happen in this case is that this gets squeezed inwards like this. So everything gets squeezed inwards like this. So it will then become the new function would be something like that. It will get squeezed inwards, and there's a reason why it gets squeezed. If you try and if you view it like this, hang on. So you've got your function here like this. Let's see. Let's say this is 1. So 1 is here. 2, 3, 4, 5. Let's say here. It could be any function. Okay. So 2 is here. 3 is here. 4 is here. 5 is here. Okay. And the same could be true on the negative side as well. So negative 1 is here. Negative 2 is here. Negative 3 is here. Negative 4 is here. Now, at the moment, this thing is f of x. Okay, in our case, it's f of x to the power 3, but it could be any function. Now, if you want to investigate what happens when you have f of k of x here. Now, choose a simple number that you can put into the k, just so that you can understand what's going on. So let's choose k to be 2. So let's investigate this here. Okay. So now this purple line at the moment is f of x. Okay. Now we want to know what this new function will look like, f of 2x. Okay. So let's select when x is 1. So our new function must lie somewhere along this dotted line here. So if you put 1 into here, it's like you finding out well, 2 times 1 will be 2. So it's like you using f of 2 of the old function. So along this line, hang on. So we are trying to find out this new function here. Now when it's at 1, you would put 1 into this thing here. So we are trying to find out a dot along this line when x is 1. So and it turns out to be that we need f of 2 of the old function. Now 2 of the old function is here. So our new function, you see, we are stealing this point here. This is f of 2 of the old function. We are stealing it and putting it here. Okay. Now we are trying to investigate this function here. Let's have a look at it when it's 2. So when it's 2, it's going to be somewhere along this line. So when we put 2 into here, this whole thing here will be f of 4. So in effect, along this vertical line here, when it's 2, when you put 2 into here, this in effect becomes f of 4 of the old function. So 4 here of the old function is here. So it gets shifted across. Well, you can see that it's being squeezed. Hang on. Our new point is here, and then if you look at, let's say when it's when looking at this new function here, when it's negative 2, so this one here is negative 2. Okay, when it's negative 2, put it into here, so it becomes f of negative 4. So that means you've got to steal the f of negative 4 of the old function. So at negative 2, I know this is a bit weird, but it does make sense. It's just me not explaining it clear enough. Well, anyway, when you are trying to find out the point on negative 2 here, it becomes. Sorry, let me start again. We are trying to find out a negative 2 for this function here. So you would put the negative 2 into here. It then becomes f of negative 4 of the old function. So this is negative 4 of the old function here. So it's here. So it gets moved across. Well, it will be like this. So it turns out that our new function will be something like this. it would be exactly the same, but it gets squashed. It gets squashed inwards. Everything gets squashed inwards here. It's really hard for me to explain this, but there is a reason why when you have f of x, let's say f of x it's like this. There is a reason why if you have f of 3x here, it gets squeezed inwards here like this, and there is a reason for that. It's really hard for me to explain it, but I hope I've done enough for you to get a rough idea of what's going on. Okay.